Welcome to Q&A Wire.
So in this problem, we're going to look at problem 60, which is another look at problem 31, and look at it with the software. And I just looked at some of the effects of a pump and turbine efficiencies, and looked at the reversibilities with each of the processes. And I drew the actual cycle here, which is a kind of a reheat cycle. Oops. So this I did it with a pump efficiency of 1, because the pump efficiency, you can't even see the difference if you change it, um, and a turbine efficiency of 80%. So it's a reheat. So we start here, we pump it up. You can't really tell the difference. Then we come up and heat in the boiler till we get up to this point here. And now we start vaporizing, so we get generating steam. So then we get superheated steam. And then we bring some of it out and get it down as it drops down to a pressure of, I can't remember what was that lower pressure. Let me look at my code. What do I have for the lower pressure there? Let's see here. 4 is 2 megapascals. So this is 2 megapascals, and this was 6 megapascals. And down at the bottom, we're at 20. All right, so when we take some off the turbine, and then we don't come back here. This is just an extended line. We go to here. We go through the turbine here, and then we heat it up again to back to here. And these temperatures are 400 Kelvin up here. No, 400 degrees C, right? Because you can see that they're, whatever they are here, 700 Kelvin, basically, somewhere around there. So then we have it's not isentropic, so you can see here that these lines aren't vertical. So we have more entropy at 4 than at 3, and then more entropy at 6 than at 5. Let's see here. So yeah, we come up here, and then come back here in the condenser. So here I looked at the total exergy destroyed, or the exergy, basically the specific exergy destroyed in this cycle as the efficiencies change. And again, you can see that you can kind of discern a little bit of a difference as the pump efficiency changes, but again, it's very, very small. So the minimum is out here when both efficiencies are 1, and then up here, I think I went to 70% for both of them. So we have a maximum here, and let me see, I can tell you what those numbers are. If I look in okay, I went from 75. So 75, oh, let's see here, I guess I didn't, I totaled them all up, and I didn't actually print out the totals before I plotted it. So let me actually just do this. Let's see here. That is 598 on equal out 598. All right, and so let's do a totaling operation here. And okay, so we get, let's see, this is down here. Oh no, up here we have 268 kilojoules per kilogram, specific exergy destroyed here, and down when we're at the other extreme, we have about 241 kilojoules per kilogram of exergy destroyed down here. So we have about, a change of, we have a change of 240 to about 30 kilojoules per kilogram. So again, we can see that, the big thing is that you get more exergy destroyed as the efficiencies go down. But again, the pump doesn't matter a whole lot. Now we can also look at the exergy or the irreversibilities in different processes, and these are the ones that are affected by the turbine efficiency. And then I'll look at the pump efficiency ones later. So again, we got to worry about whether this is in the vapor dome or not. So I took a look at X6, and so that's why I only went down to 75%, because otherwise we wind up outside. As this gets more and more inefficient, we wind up with a superheated vapor coming out of the turbine. So this is the exergy destroyed in the condenser. This is the exergy destruction in the turbine. It's like the second phase of the turbine. And then the exergy destruction in the first phase of the turbine. And you see those go to zero when the efficiency of the turbine goes to 100%. And then this is the exergy destruction in the reheat cycle here. And I'm not sure why I didn't do plot 2, 3 there. Does that make much of a difference? Let me see here. Why did I not do 2, 3? Let's see here. This is, I gotta look at what the output parameters are here. Too much code. Let's see here. 2, 3. Why didn't I not look at 2, 3? Did that not change much? Let's see here. 2, 3 is the boiler. So let's see here. 2, 3 is the 1, 2, 3, 4, fourth output parameter. So let's see here. 1, 2, 3, 4. No, it doesn't change. It doesn't. Oh yeah. Of course it doesn't change, because it's before we get to any inefficiencies here. So yeah, of course it doesn't change. So that's why I didn't plot it there. Anyway, that's what you can see here. So the exergy destroyed actually in some cases goes up, goes down as the turbine efficiency goes up or goes down. And that's just because we're in this part of this reheat cycle. So it's basically just that you're not getting as much here. You're coming more here to here than when your efficiency goes down. So that heating is less, so you have less exergy destroyed there. So that's why that's happening. And again, we got to make sure we have a two-phase coming out of 6. And now, if we look at the pump, there's two things that the exergy or the irreversibility processes of the pump changes. So as the pump efficiency goes from 1 to 75%, the irreversibility from 1 to 2 through the pump goes from 0 up to about 1500. And is this, hold on a second, I think I labeled that wrong. Yeah, this is 1, 2. Yeah, this is joules per Kelvin, joules per kilogram. So the thing is it's pretty small. So 1 point, I think what was the max? About 1.8 kilojoules per kilogram here from 1. So again, as opposed to these things, and again, that should be joules per kilogram. Compared to these, this is just negligible. And then we can see that, in fact, the pump efficiency also affects the irreversibility in the boiler. But again, it's almost, just look at the scale here. It's hardly any, there's barely any change here. So again, the pump efficiency really has very little effect on things.